Wonderful. I think we are going live. So if you're watching this right now live on LinkedIn or YouTube, very excited to have you. We're just going to wait another minute or so to get all started. We're just getting all set up here with the BatteryMBA cohort who are joining us here as well, live as well in the back end. It's very good to have you here, Eric and everyone. Good to see you. Today is a bit of a special session, so very excited for everyone here. And of course, also everyone watching this live on LinkedIn, YouTube, big welcome to you. Thanks for joining us for that as well. And hopefully you can engage with us. Keep your questions coming in the comment section, either on LinkedIn or YouTube. Of course, we would love to hear from you as well. Again, this is an open platform, so very excited to have you all with us. So we're here today with the 11th roundtable of BatteryMBA. Time really flies, so it's been quite a few cohorts. So really excited to have you back with us. We're doing this roundtables as part of the BatteryMBA program for the final week, where we're kind of really having a bit of a wider look at the topic of perspectives on the future of batteries. We take a bit of a thinking head on and think about what might be coming. And again, this is also together with Battery Associates, who's running the BatteryMBA program. So we just go to the next slide, please. It's just a quick welcome from me for our speakers before we're going to introduce them all one by one together with Shada, who's co-moderating the panel with me. But for now, we're not going to go in much depth of our speakers because we have time for that later. But we already have Dr. Aaron Wade with us, who's the head of battery costs at CIU Group. We also have Dr. Jennifer Chanel with us, who's commercial and partnerships lead at Enafite. We also have Rob Johnson with us, who's the former global purchasing director at Jaguar Land Rover. So I think a really exciting panel, some great perspectives. So really excited to have them all with us today. Really appreciate for you to be here. But for now, let's do a quick intro who we are as Battery Associates as well as the BatteryMBA. With this, I want to pass on to Melanie to introduce that. Thank you.
Hello, everyone. I hope you're all having a great summer. As a quick introduction to Battery Associates, our mission is to create a sustainable world through the power of people and battery innovation. We do this through three main arms: Battery Pro, which focuses on consulting and customized training to support businesses in their transition to a battery-powered world. Also through Battery Lab, which is our innovation hub, where we aim to bring about affordable and innovative battery solutions. And finally, through Battery EDU, which is our education and training hub. Here we aim to train a diverse and global battery workforce through our training programs, including our flagship BatteryMBA program. For those who don't know about the BatteryMBA, it's a CPD accredited 12-week-long online program that we offer 3 times a year. We have more than 520 alumni from over 50 countries, featuring more than 30% female participants. Professionals who participate in our program come from leading organizations in different stages across the battery value chain, such as Tesla, Li-Cycle, PowerCo, Jaguar Land Rover, Esvolt, BASF, prominent in universities worldwide, and many others. The program is meticulously structured to accommodate full-time professionals with a manageable time investment of 2 to 3 hours per week. If you're keen on joining this program, we invite you to apply for our upcoming cohort starting in September, which is on the next slide, using the link seen here on the screen. Additionally, we're pleased to offer a range of scholarships designed to facilitate inclusion of individuals from groups that are traditionally underrepresented in the battery sector. If you have any questions, feel free to contact us at info@battery.mba. We're also excited to share that our 5th annual event, Battery Day 2024, is upcoming and scheduled for the 26th of September. This is a full-day online event featuring leaders from various industries across the value chain and showcases both panels and deep dives on pressing battery developments. We invite you to register using the QR code here or the link provided. Now, I'm going to turn it back over to Simon.
Thank you so much, Melanie. And that's also something really exciting we have seen now with our community meetups. And we have been bringing together a range of BatteryMBA alumni as well as ambassadors and partners of Battery Associates over the past few months. So that's something really exciting. You can see here all the way from China to the UK, as well as in Germany, as well in the US. And we actually have 2 already planned again, or 3 actually planned next, which are in October in India, as well as in the US, and then also in Germany again in November, and we're doing this as part of the US Battery Show, India Battery Show, and the Future Battery Forum in Berlin. So that's something we're really excited for. And I think really, speaking volumes now that we have more than 500 participants and alumni, and of course, this current cohort being part of that very, very soon. So I think that's just a really exciting involvement we have seen to also go more into the physical world, as we also spend a lot of time together online in these programs, but we're also really keen to bring you together in person. And just as a quick note for all the alumni watching, please find us in any of the events. We have some very special tokens of appreciation and new merch. So, I would love to share this with you as well. So please find us in any of the events we're attending. As you know, you can find us through the emails and the event calendar we're sharing that way. Great, and I think we will go through this in a moment. So for now, let's please go on the next slide, introducing our speakers of today. And Shada, with this, I would like to introduce our first speaker. Thank you.
Yeah, thank you very much. Good morning, good afternoon, good evening, everyone. Welcome to today's panel discussion on the future of batteries and energy storage. We're really delighted to have you today and delighted to have an exceptional lineup of experts with us today. And first, Aaron Wade joining us. Aaron leads CRU's battery cost modeling team, specializing in forecasting the production cost of both current and next generation battery technologies. His work focuses on understanding how and when new technologies will impact the battery market. Prior to joining CRU, Aaron earned his PhD in lithium-ion battery degradation from the Faraday Institution at University College London, during which he also completed a part-time internship at Exawatt. Additionally, Aaron serves as the project director for BatteryPub, an online networking platform designed to connect and engage the global battery community. And I hand over to Simon for Jennifer.
Thanks so much. And yeah, it was Jennifer, Dr. Jennifer Channel. She's the commercial and partnerships lead for NFI Limited, where she leads the commercial and marketing functions to bring NFI's dry battery electrode process technology to market. Jennifer has been instrumental in growing the UK battery industry through her role as innovation lead for the UK government's Faraday Battery Challenge. Jennifer is also project director for Europe for the Volta Foundation, a not-for-profit dedicated to advancing the global battery ecosystem through community. Jennifer has a PhD in chemistry, is a battery ambassador for Battery Associates, and is a professional member of the Royal Society of Chemistry and IOM3. With this to Rob. Thanks, Shada.
So last but not least, Rob Johnson joining us today. Rob has a distinguished career as an executive in global automotive supply chain. Most recently, he served as a global purchasing director at Jaguar Land Rover, where he was responsible for procurement related to battery propulsion, among other commodities. Earlier in his career, he was a vice president of purchasing at Toyota Motor Europe. Currently, Rob holds the position of honorary professor in purchasing and supply chain management at Nottingham University Business School. Additionally, he serves as director of Deepfarm Limited, a technology spin-off from Cambridge University, and as an advisor to Invoice Limited, where he specializes in helping battery and automotive companies enhance operational and supply chain sustainability.
Brilliant. Thanks so much, Shada. And let's go right into it. And maybe we can also remove the slides for now to kind of make us a bit bigger here and start with Aaron for the first question. Would love to have your take on, especially on the topic of cost. I know it's something very passionate about. People who know you from LinkedIn, etc. I know you're also quite active on that topic. It would be really great if you could share a bit about the topic of, what are biggest drivers of battery cost today, what you might expect for the near future, and also maybe how you see maybe the balance between cost reduction and also technological innovation shaping the future.
Yeah, sounds good. Great to be here. Thanks for the invite. And yeah, love talking about battery costs. So happy to do that. So if we look at the cost of lithium-ion batteries today, the biggest single cost component is really in the cathode active material. So this can make between 30 to 50% of the total cost to produce a cell. And that obviously depends on the chemistry and the type of cell and a whole range of factors. And then moving to, let's say if we're NMC 111, moving up in nickel content, where we increase our energy density can help decrease cost. And we look at within the CAM and within the cathode active material, the biggest single cost component is really the lithium price. We saw back in 2021, 2022, the lithium price really spiked and got very expensive. So lithium was sitting at about $9 a kilogram before, went up to about $70, $80 a kilogram during that period. And now we're on the way back down, and we've come all the way back down to about $15, $20 a kilogram for lithium carbonate or hydroxide. So during that time, we've seen a huge spike in lithium price, and therefore the cost to make CAM and then the cost to make our batteries really increased. And then now we're on the other end of that. And this is why we're seeing very low pricing at the minute, in part, is because the lithium price is very, very low, and that's driving these low cost to produce cells. And then if we look regionally, there are big discrepancies between different regions as to how much it might cost to manufacture a cell. Chinese companies based in China have the lowest production costs of all. There are several reasons for this. One really big one is because of vertical integration. So Chinese companies have big ownership in mines, cathode plants, anode plants, and this helps them get those cheap raw materials, that cheap lithium, which helps that vertical integration. But the engineers in these factories have really optimized the production process. And one really good example of this is in the yield step. So we see Chinese factories are operating between 95 to 97% yield, so really throwing away not very much of their materials, where we see factories in the rest of the world during the ramp-up phase, be it kind of 40, 50, 60%, and then struggling to get up to that 90, 95% level. So not only can Chinese companies procure their materials cheaper, but they also waste less of it, so therefore more ends up in the final batteries and then drives those costs down. And then I guess the final reason why Chinese companies have these low costs is because of labor requirements, looking at fewer workers due to optimized production, as well as a lower wage that we pay our workers over in China. So therefore these production costs for Chinese companies are much lower, which is keeping the cost to produce very low at the minute. So I guess to wrap up that section, low material price on the lithium side is helping low production costs, and then optimized factory performance, especially in Chinese companies, keeps these costs low. And then I guess if we look to the future and where things might go, there's really two ways to reduce cost. One is to get cheaper raw materials, and one is to increase the performance of your materials. And then on the raw material price, these can only come down so low. So if we look at what happened in the solar industry, which is a very analogous industry to the battery industry, we saw for a long time that costs of silicon fell and fell and fell and fell. And then it gets to a point where they can't fall any further. And then in solar, you have to increase efficiency. In batteries, we look to increase performance, typically energy density. So this might be moving from LFP to LMFP with kind of limited increases in material costs, but good energy density gains, or potentially by doing step change innovations like lithium metal or solid state or something like that. And then finally, the other option is substitution. So instead of doing a lithium-ion battery, we could do something like a sodium-ion battery with inherently cheaper raw materials in theory, which offsets that lower performance. So I guess overall, lithium-ion battery costs are pretty low at the minute, driven really by that low lithium price. But we see that technology innovation, maybe LMFP, maybe sodium-ion, potentially lithium metal or silicon anode further out, can help drive these costs even lower in the future.
Fantastic. Thanks so much for sharing. And I think we might have a bit of more debate because I think there's a lot of factors, right? You already touched on overcapacity and all these other kind of also interesting developments regionally as well. But yeah, maybe just a quick also note for all the people watching this live right now on LinkedIn and YouTube, etc. Before we're going to ask some more questions, feel free to also put your questions in the chat because this is really your chance. The first 45 minutes is public to you, so we can ask your questions. So please make sure you add your questions on LinkedIn and YouTube. But with this, I want to pass on to Shada for the next question.
Thank you very much. That discussion was really interesting about the strategy to reduce the cost of lithium-ion batteries. Now, my question will be for Jennifer. So, as you know, Jennifer works at NFI, and they develop dry electrode manufacturing technologies. So, Jennifer, since you been developing cathode powders for producing dry coated electrodes. What are the key advantages that dry technology provide us in terms of cost or manufacturing, and as well as, can you also mention the challenges in dry manufacturing and scaling up this technology with respect to, of course, the traditional wet coating technologies? Thank you very much.
Yeah, of course, happy to. I mean, one of the big benefits that dry coating offers speaks a lot to what Aaron was talking about with respect to cost. So cost saving is a massive benefit of dry coating, and the other major benefit is sustainability or compliance. So speaking first to cost, so Aaron already talked about kind of materials hitting their kind of price floor. So another way to reduce the cost of batteries is to address the processing cost. So what dry coating aims to do is to remove the massive long drying ovens that you would find in a gigafactory that's typically used to remove the solvent from the slurry casting process. So you're getting rid of CapEx costs, but also OpEx costs, because you don't need to fund all the energy that's required to power these ovens. And it's about 30% of the battery production process. 30% of the energy demand comes from the drying ovens. So then the other aspect is kind of sustainability and compliance. So obviously, if you're getting rid of the big long drying ovens, you don't need as much energy to power your gigafactory. So if you're in an area where you don't have access to clean energy, then you're massively reducing the kind of carbon footprint of your battery. And then also there's the issue of removing solvent as well. So not needing to do the coating process using a toxic solvent such as LMFP means that you can improve the sustainability of your battery as well. But there are still some issues with this. So at the moment, for a cathode, the typical binder that you would use in a slurry coating process is PVDF. And for a dry coating process, most of the industry is working with a fibrillating binder called PTFE, which both of which are hard to recycle. They're often referred to as PFAs or PFAS. And PTFE is just as difficult, if not a bit more difficult to deal with. So that's a challenge that the industry's got to work with. How can they improve the design for recyclability using perhaps binders that don't contain PFAS? And thinking about that kind of longevity perspective. Other issues in terms of scalability, again, coming back to the binder aspect. So if you're dry mixing the materials at ton scale using a binder which fibrillates under heating and friction, then it can be very difficult to scale this up, and you get a big sticky mess. So finding solutions to that challenge are quite critical. There's also issues with safety. So at the moment, the kind of state-of-the-art wet coating slurries, for example, electrodes would contain advanced carbons like a carbon nanotube. If you want to use that in a dry coating process, if you were to put that into a dry mixing situation, you're basically putting asbestos in a blender. There's a severe process inhalation risk. So finding novel ways to introduce the high aspect ratio carbons, which give you that advanced performance, are really critical. Aaron also spoke to the point about getting the most out of your materials and improving performance. So we don't want to find ourselves in a situation where we're having to reduce the performance of our electrodes just to access this kind of cost benefit. We also want to make sure that we're making the most of those expensive materials. So finding ways to increase the the percentage of active material, reduce the amount of inactives in there, and get the best performing electrode is really what we're trying to do. And at Anaphyte, these are the challenges that we solve with our dry coating precursor process.
Thank you very much, Jennifer. Yeah, it's really interesting to know, especially the issues around binder selection. Probably it is really limited choice for the dry coating for the moment. And scale up and safety would be two other challenges of dry manufacturing. I would like to remind again to all the people listening to us today, please send us your questions on LinkedIn or YouTube, and we will address them during our conversation today. So I think now we can continue with Simon for the next question to Rob.
Absolutely, and great to see people like Sonu and Jay and others on LinkedIn saying they're really enjoying the conversation, introducing themselves. So looking forward to your questions coming in there as well. Yes, now I'd like to come to Rob, and I think really fascinating with your background in automotive or OEM. As you've worked extensively in that sector, maybe how do you look at the drop in demand from EVs, and maybe what are critical success factors you could see to push back the demand and get demand back? And maybe also a bit of, from your experience, how has the pandemic impacted the supply chain, and how do you propose you make it more resilient, especially in light of climate change related unforeseen circumstances with this? What do you, Rob? Oh, sorry, Rob, you're muted right now.
Yes, thanks, Simon. Sorry about that. And good afternoon, everybody. Yeah, I think anybody working in and around the battery industry will be watching intensively what's going on at the moment, because I think my summary would be we're in a state of flux or change going on at the moment around demand. And we're seeing a slowdown, as we know, technically speaking, in the global growth of EV adoption. So EVs are still growing around the world. That's good news. But if we look at the rate of growth, it's definitely slowed. Everybody will be aware of that. I saw some figures from Motion recently showing still growing from 23 to 24 half year result, about 20%. So still some growth. But that, if we compare to the previous year, 34% global growth, 55% the year before, you can see that it's slowed, and it's certainly behind where most of the industry observers were predicting. So battery penetration market share is about a fifth of the total global market at the moment, which is probably a little bit behind where I think the industry needs to be, at this stage of its development. But on the good side, if you look at a lot of forecasts going further out, I saw some from EV Volumes, JD Power the other day. They're still forecasting 40 million vehicles, about half the global market by 2029, from where we are today, maybe 15 or 16 million. Bain, we're talking about quadrupling of gigawatt requirements by 2030. So, the underpinnings of the industry are still there, but what we're seeing is this very distinct slowdown. There is a clear marked regional disparity, though. Everybody will be aware of that. So if we see and look in China, which is by far and away the most important market, their sales are still up 30%. And the penetration of electric vehicles overall is nearly half the market. So that's by far and away the most important market, as we know. Europe's market share for electric vehicles about 35%. US is down at 8%, and the growth levels have slowed quite markedly in those two markets. So it's quite pronounced. The regional differences that we're seeing are more than we expected, certainly in Europe and the US. So we're getting stories, lots of reports about overcapacity, overproduction going on, both at the EV and at the battery cell production levels, overcapacity, particularly in Asia. On top of that, don't forget there's a distinct swing out of full electric vehicles towards plug-in hybrids. So that's very pronounced around the world and is a very important factor that we're seeing. It's affecting, therefore, some regions more than others. But you can see that in China, for example, nearly 3/4 of the market in battery vehicles is plug-in. 2/3 of the market in Europe, a little bit less in the US. So, are plug-in hybrid the interim step that everybody expected? Is a question that everybody's asking themselves. Lots of car companies are now announcing that they're pushing back the rollout of their new electric vehicle models. Companies in different regions are facing different problems. If you look around, the financial results of a lot of electric battery companies, electric battery manufacturers, they are now starting to show some financial signs of distress, if you like. A lot of the car makers that are soulless electric vehicle, like XPeng, Dongfeng, like Zeekr, NIO, Leap, and others, Rivian, Fisker, you can see are starting to drift into financial issues. So I think even Tesla have seen a halving in its profit before tax over the last 5 years. So a distinct change in the market as we're moving out of what we might call, early adopter phase to mass market phase. So as Aaron and Jennifer have already mentioned, real focus now on everybody in the market around costs, reducing your production costs, leveraging the value chain, and lowering the cost of all the minerals and the chemistries that we're using in the battery. And we're seeing some changes in consumer sentiment that are driving some of these changes, in a sense, hesitation in the marketplace around costs, particularly around charger distribution, around government incentives. And of course, we're even seeing issues to do with trade tension between the different parts of the global market. So, yeah, the market is now in a state of flux. Survival is not compulsory, as I often say. And I think the companies that are going to survive in the future are going to be those that can be the most agile to this kind of adapt to these changes that are going on, and are going to be the most competitive in terms of getting their costs under control and stable.
Excellent. Thanks so much. I really appreciate the insight and a takeaway, state of flux. I think it's
that's right.
Good way to look at it. I think with this, Shada, I would like to pass on for your next question.
Yeah, thank you very much. So we have a quick cross-funnel question, and after that, we can take some question coming in from LinkedIn, and we can maybe quickly address this question to all of the panelists. Given the rapid advancement in battery materials and technologies, how do you foresee the regulatory landscape evolving to ensure safety, sustainability, innovation in battery manufacturing and deployment? Who wants to take that question first? Maybe Jennifer?
Sure. Well, so I think we're seeing a lot of evolution in that space. The EU battery regulation that's coming into play is kind of a landmark regulatory framework for the battery ecosystem that everyone's having to adapt to, that I think is certainly driving innovation, and also making countries, particularly very established players like China, think about how they're going to continue to sell into the European market. Obviously, China's had over a decade of scaled battery production, whilst they kind of made all of the mistakes that they were going to make, and now that they can turn their hand to really making their battery ecosystem incredibly green. So I think it's going to be quite difficult for North American and European markets to both get to scale and within strict frameworks like the EU battery regulation. We're also obviously seeing as well on the more kind of policy incentive side, there's a real kind of incentive and kind of disincentive wars going on at the moment between the three main manufacturing areas, Europe, North America, and Asia. Things like the foreign entity of concern policy in the US about whacking massive tariffs onto Chinese manufactured BEVs. Also things like the IRA and bipartisan infrastructure law that we've heard a lot about in the last year and a bit, that have really helped North America to make massive investments in securing the future. So I think we're only going to see more of this as we go forward, and it's going to be really interesting to see how it kind of plays out, where there are continued restrictions on the major nations like China, and how what levers they will pull to ensure that they can continue to retain and gain more market share.
Yeah, thank you very much, Jennifer, for these insights. Yeah, there are a lot of incentives to slow down the China, of course, and promote, let's say, regional battery production from both Europe and US. Aaron, you want to add something on this question?
Sure. Agree with everything Jennifer said. But I think it's interesting to look at some of the policies that have come in place within the Chinese ecosystem. So one is the banning of NMC for Chinese BESS, which has really helped accelerate the uptake, especially LFP and potentially sodium ion in that space. And then the second is looking at the standards that they're setting and the minimum requirements that your cathodes or cells have to be achieving to enable government subsidies to be continued. And these standards are being continuously pushed and accelerated, which I think really shows the appetite for the Chinese industry to continue to innovate, continue to push their materials, and potentially make it harder and harder for non-Chinese based companies to come and enter the space as these Chinese companies improve their materials and ship them around the world.
Yeah, thank you very much, Aaron. Yeah, excellent point. Yeah, China continue to innovate and continue to advance their technology and try to catch up with what is demanding now from the West, basically. And Rob, do you want to add something on this?
Yeah, but perhaps just to add maybe some supply chain observations as well. As Jennifer mentioned, the EU battery regulations. I think what's interesting is this is probably one of the first examples I could think of where government, consumers, and investors' concerns are being encapsulated into, really strong regulations that are now around product integrity, also around ESG, as Jennifer mentioned. Europe is leading the way. Maybe the US will follow, I think, and maybe parts of Asia will follow. And ultimately, the whole global kind of infrastructure will need to take a look at what these regulations require. But from a supply chain perspective, they're very, very important, because what we're really talking about is, what's happening down your supply chain matters. The digital passports that will come into play with the battery regulations will mean that the whole life cycle matters. Right back to the mine, you'll need to account for, what's happening in your supply chain if you're a battery manufacturer or seller. So, CO2 measuring, responsible sourcing around ESG concerns, around labor terms, around working conditions and fair wages and so forth, right down your supply chain, recyclability and recycling targets and so on. So as we've already talked about, this means the whole industry needs to move a kind of quantum leap, actually, from supply chains in terms of supply chains to manage the vertical supply chain right down to the source of the minerals and the chemicals. And that is something that's new for this industry, but it's also something that's really quite new in supply chain management. So I think, again, we talked about a revolution earlier. I think this is, again, an industrial revolution for the value chain. And so, again, I think competitive advantage will come to those companies that harness it the most effectively and the quickest to the market with it.
Excellent. Thank you very much. Yeah, that's getting really an exciting discussion. I think we have now many questions from the audience from LinkedIn. I think I hand over to Simon for a couple of questions from the audience.
Thanks so much, Shada. And I think, it's wonderful to see all these questions coming in from Soma, Renee, BatteryMBA alumni, and Yannick, and Sonu, Asina, Didier, Faisa, Justin, and Jade. So a lot of questions. So let's get ready. And we might do a bit of a speed round in the end to make sure we address most of them, or hopefully all of them. I think the first question I would like to go with is from Justin. I think it's maybe also a bit in your quote, Aaron, but of course also happy to have anybody else thoughts on that. So here we're looking with the increased energy density of LMFP. How do you foresee the market share of NMC batteries and other, I guess, nickel-containing chemistries?
This is a great question. partly because it lets me do a nice little plug, which is we're doing a webinar on this exact topic, the battery share, on Thursday. So if you're interested in hearing CRU's thoughts, please do come along. But I think LMFP is a really interesting and exciting technology because minimal cost increase, relatively good increase in performance. However, cycle life is still pretty low and adoption is incredibly low because of that. So I think in the short term, it won't displace NMC. Maybe in the medium and longer term, as cycle life improves, it will. Currently in China, it's being blended with NMC, so kind of used in hybrid. So maybe we'll see more and more LMFP in those blends over time as the performance starts to improve.
Perfect. Thanks. No, thanks for the plug. Might check that out. Great. I think Shayla, do you want to ask the next question? Or do you want me to go? I can also go otherwise.
Yeah, I can ask the next question. Faisal, he's from Morocco, and he thanks very much for this excellent discussion. And his question is, what are the challenges and recommendations of sodium-ion technology? Maybe Aaron, you want to continue on that, or we can maybe Aaron and Rob can collectively answer this question.
Yeah, happy to go. Rob, do you want to go or should I go?
No, I think it's a technical one, Aaron, that you're probably best suited to talk about, I think.
Cool, perfect. So I'm really interested in sodium ion for a couple of reasons. One is if you want to build a supply chain that isn't dominated by Chinese companies, it's going to be quite difficult to do that if you don't adopt sodium ion, simply because Chinese companies have really big ownership of the lithium mining, the anode space, the cathode space. Currently on the cost side, the real limiting factor is the anode. So the anode is typically hard carbon. It's made very similarly to how graphite is made, but there's just not really a supply chain for it yet. So the prices are very high. They were even higher. They're coming down as more people produce the material, but it should keep coming down, which will enable sodium ion to be cost competitive. And then on the performance side, I mean, sodium ion technology won't be as energy dense as lithium ion, simply because sodium's heavier elements is pretty difficult to overcome that on the energy density and performance side.
Thank you very much, Aaron. Anybody wants to add anything on sodium ion, Jennifer or Rob?
Well, just not specifically about sodium, but I think the point that Aaron touched about, I think the technology race that's on around energy density and looking for different minerals and chemistries that can give us the best solution is critical technologically and technically speaking, cost speaking, but it's also from a supply chain risk point of view, critically important. And as one or two people have already alluded to, China right now dominates the refining side of the business for historical reasons and because they are by far and away the most important market. And for other parts of the world to get a slice of the action, if you like, in what will be a global industry, it's important that they can build up their own mineral solutions and mineral processing solutions that can compete, if you like, with the dominance that we can see in China. And if you think about cobalt or nickel or lithium, the refining of those minerals is dominated out of China at the moment and is likely to remain so when even many of those refining systems go out and globalize. So if there are new minerals like sodium, to Aaron's point, which can be exploited and are readily available and low cost elsewhere in the world, then that's a great opportunity for indigenous manufacturing and refining to go on somewhere else in the world. So we should look to do that to diversify and improve the choice and competition of the industry.
Brilliant. Thanks so much, Rob. And I think you're kind of, tying some good questions together because there's a lot of discussion about China and questions about China now. I think we can maybe address this a bit more, maybe get also your thoughts on this, Rob, but maybe also Jennifer from a processing standpoint, because there's also some questions on dry coating. And yeah, I think it's also kind of nicely aligned. I mean, Aaron, you are plugging your webinar. Maybe I plug some of our videos we just released on China, because we spent a few weeks there and we recorded many videos. We released one just today on lead acid, which is one of these other technologies many of us don't really think about much. But there's also some interesting business case to be observed in China. But of course, also sodium ion and other technologies we released over the past weeks. But now to the question for Rob, and I will kind of tie Renee's and Yannick's question a bit together. So the question was from Renee: with low production costs by Asian players, technological hurdles at domestic emergent players, how do you assess the viability of EU headquartered gigafactories such as Northvolt? Should they focus on newer technologies such as dry coating? Here may be a link to Jennifer, LMFP, or stay with the same field as the Asian players. And that's also, I think, Yannick, in the same line. The question is whether Europe can compete with China, as the markets are predicting to be flooded by cheap EVs from China, BYD, say Xpeng, etc. So maybe Rob to start with, maybe Jennifer to add some technology.
Yeah, it's a great question, because I saw some information the other day that I don't know what the number was precisely, but it's certainly over 30 new plants are either under construction, or some are in existence. Of course, some are under construction or being on earmarked to come on stream in Europe. And there's a similar picture if we go to North America, and even a bigger picture, as we know, in Asia. So I think it's going to be a combination of what we might call transplants. That means we'll see inward investment, and we are seeing inward investment from a number of the big, what we might call global battery players, from China, from South Korea and Japan, coming to Europe to produce locally here. And also we've got hopefully a number of, let's say, indigenous local startups like Northvolt and others that can make it through and offer solutions. But as the questioner asked, the key one is how to be competitive at the end of the day, and there's no free ride for anybody. So quite right, I think the question was saying, are there ways in which you can become more competitive through technology? There has to be, I think, for you to be successful here in Europe, which is traditionally a higher cost base. And also, how can we improve the production method and let's say, lean the systems out? What we shouldn't forget is, the internal combustion engine has had 100 years to improve its manufacturing processes, and the battery industry, to be fair to it, has only had a decade or so. And so there's a long way for us to go in the battery industry to match up in the performances and the manufacturing efficiencies, yields, and the OEEs that we need in the battery factories and so forth need to be honed to perfection, let's say, in order to be cost competitive. So there's a lot to do, and there's no reason why Europe can't be at the forefront of that and be competitive, in my view, provided it's well managed.
Yeah, I absolutely agree, Rob. If you copy and paste a gigafactory from China and put it in Germany, the German one's going to be more expensive. There's just no way of getting out of that situation. So process innovation is going to be absolutely key for Europe and North America to achieve a lower cost, better performing battery. So yeah, that's my aim. That's absolutely my perspective as well.
Excellent. Thanks so much. And with this, maybe Shada, do you want to ask the next question?
Yeah, perfect. So we have a cost-related question now from DJ. What is the target battery cost that the automobile industry would consider to be low enough to address the needs of the mass market for EV? It used to be $100 per kilowatt hour. Is the magic number, or much lower now? Who wants to take this question? Again, maybe Jennifer, you want to take, and we continue with Rob?
I can speak generally.
Yeah.
Lower cost is always going to be better for mass adoption. Rob spoke to this point earlier. We've seen the early adopters, and now we're at the mass adoption phase, and cost is absolutely king in that equation. I think there's, the materials price is an interesting one, and we've seen how volatile they are and how much that impacts the cost of the battery, and it's been dropping over years, but we've seen an inflection point as well. Again, processing costs could be a way to help stabilize that cost. But I think when we think about the mass European market adopting EVs, cost is going to continue to be important. Maybe Aaron has more specifics on the numbers and the trajectory of packs, but yeah, I agree.
I'll give a typical very annoying answer, which is it so depends on the size of the vehicle, what the battery size is going to do. I mean, we previously saw battery sizes increasing, but now that's started to come back down, and we think it will continue to decrease. So if your battery size is decreasing in terms of kilowatt hours and your dollars per kilowatt hour is decreasing, your total dollars that you're spending on the battery is obviously coming down. I think maybe the target would remain at $100 a kilowatt hour, but there's going to be continuous innovation to push those costs even lower to really enable, I guess, quicker adoption of electric vehicles, which is something I think that we're all kind of hoping for and rooting for, especially on this call.
Yeah, maybe just to add to Aaron's comments there. I mean, I think, I've put my old purchasing director's hat on, unfortunately. My view would be, and I would say this to the battery suppliers, I want parity. So in other words, I want, through the technological and process innovation that we talked about, I think the market wants electric propulsion systems to be essentially the same price as internal combustion engine. At the moment, certainly the data, going back a few years from my time, was that there was a significant cost penalty to fit electric propulsion system. And on a like-for-like basis, we know if we're going into the dealers to buy a car, we're facing 30 or 40% cost difference to buy an equivalent car in electric vehicle mode versus an internal combustion engine. So I think the industry has to eradicate that gap, and that's easier said than done. And it may take longer than simply a couple of cycles, let's say. But I think that's ultimately where we've got to get to. That really, this new technology should offer us ultimately lower costs, and the industry's got to figure out how to do it, and it's got to figure it out very quickly.
Yeah, just to add to that point, I think most of the European market's been focused on introducing more premium vehicles as their kind of market leading BEV. And what that's afforded China the opportunity to do is to produce a lot of cheap BEVs that could address that gap in the market. And now Europe and North America have realized the error there and are trying to introduce ways to prevent this influx of cheap vehicles from China. So yeah, I think we need to have a bit of a rethink about what we're doing there to continue to allow that mass adoption of BEVs, but also make sure that we're benefiting regionally from that transition.
Excellent. And looking at the time, we were getting to the end of it, and of course now we get a question every few seconds, so it's we were trying to stay on top of it. So I might kind of do a bit of a potpourri now of a few questions we're having here, and you're welcome to just choose whatever you're most interested in, maybe all of our panelists. So just on a few topics we want to address. So one is, there was a topic about solid state. I'm not sure if anybody here has any thoughts on that, when this might come, when we can, a lot of people waiting for that still for some time. If there's any thoughts here, anybody wants to share anything on that? I think then there's also some curiosity about the dry coating processes from Jennifer. A bit of the question, when can this be potentially be scaled up? I think that's a question when this might come, if there's anybody brave want to share that.
Well, I think on solid state,
please,
a lot of reports, Simon, are saying, a number of car makers and battery makers are sort of saying they're close to being able to offer, let's say, in mass production, a solid state battery. But I know traditionally one of the problems was cost. So you can't add a solid state battery if you're going to add cost. But if you can get the range down and the energy density down to what is promised, then you may be able to go with a smaller battery. And as Aaron says, the trend is to smaller batteries as we extend the range and the energy density. So solid state was always seen as going to be a kind of breakthrough technology. And it's around the corner, I think, if you look at the reports of some of the car makers at the moment. But whether it will give us the breakthrough that we need in the cost area is what I'm most concerned about, to be honest.
Yeah, and I think certainly what we're seeing is that dry coating can be very important to addressing some of the cost element of a solid state battery. We've seen some announcements recently of some of the big players talking about when they're targeting bringing dry coating to market at scale. So LG Energy Solutions, they announced, I think it was just 2 weeks ago, that they're targeting 2028. Last year, PowerCo announced that they were targeting 2027, which also coincides with the release of their €20,000 car to the market. So I imagine there's some correlation there. So I think those things could go hand in hand, actually. And it will be interesting to see how the market evolves over the next few years.
Yeah.
Excellent. Aaron, anything you want to add on that? Or
I guess I'm pretty skeptical of solid state, partly because of manufacturing challenges and partly because of the challenges integrating it with the car. Specifically the pressure needed to enable those interfaces to connect. But I agree with Rob that once those technical challenges are overcome, the next challenge will be, can you do it cheap enough that it makes sense within the vehicle?
excellent. Maybe also something quick to share. Of course, there's also then the topic of lithium metal, which is not always connected to solid state either these days. And there's of course also other approaches. You can do liquid electrolytes actually with lithium metal. We just released today a podcast on that on this LinkedIn page if you're watching right now. So if you're curious, feel free to look at that as well. There's also the topic of recycling. I'm not sure if we have time for that. If there's anybody here quickly wants to share anything, the importance of recycling maybe to make it all work. Rob.
Yeah, well, the only thing is if you look in the detail of the EU battery regulations, which I recommend people take a look at those, there are some pretty prescriptive requirements around three things. One is, designing for recyclability at the beginning, and this is not just the battery system, by the way, but other parts of the vehicle as well. So can we design for recyclability? Then what do we actually get out in terms of recycling? What can we actually extract economically from the vehicle at the end of its life? And you can see a lot of car makers now investing and partnering up, collaborating in various ways on the whole issue about salvaging the various minerals and metals out of the vehicle, and including and especially battery. And then finally, there's requirements around closing the loop. So using some of those metals to put them back into the melt for the next generation of batteries and so forth. There are also other areas, of course, where we can use second life batteries, or we can use vehicles attached to the grid and use them to effectively act as an offload overload system. So there's a lot of areas in this whole area about sustainability and recycling that are going to be really important for this industry. I think it's a huge new area that the industry has not traditionally looked into.
Fantastic. No, thanks so much. I think we really appreciate your perspectives you shared on the future of batteries. I think we really went through quite a few topics here. Again, there's many more questions now. Look at also from Kamir about African-based gigafactories and many others who you shared your question. But Lisa on pricing of solid state. So unfortunately, we don't have time for this now as part of the public part. I know some similar questions already been asked here internally from the current cohorts. We're going to go into them a bit more in depth. And for now, I really want to say big thanks. Also, maybe I have one last poll Shada can pull up. We actually asked some of you before for some of your opinions, and we don't have really much time to discuss this now. Here, we might discuss a bit more internally with the current cohort, looking at some of the topics of what are the main challenges of bringing battery costs down. We've seen here expensive raw materials, something Aaron, you addressed earlier, and kind of also mentioned how the price relaxation there, the cost reduction has really helped the price to go down. But of course, going further down, raw materials are still a topic there. Also high regulatory compliance, maybe in some regions more important than others. High cost of energy, of course, in some regions more important than others, but also shortage of talent, definitely something we observe a lot with the BatteryMBA and the Battery Associates in general. So I guess that's also part of why we are here, to really trying to bridge a bit of the gap of shortage of talent through the BatteryMBA, but also many other trainings we are launching in the battery space. So for now, we want to say a big thanks for all of you watching live. I see a lot of debates going on in the chat, so keep them going. Maybe you can answer each other some questions. If some of the speakers can look at this later as well, we might also try to answer some of the questions or give you some of our thoughts in there. But really, always appreciate all of your engagement online. So really, really appreciate it. And again, if you're interested in joining, don't hesitate to look at the next cohort starting in September. Would love to have you with us there as well. It's really great fun. With this, thanks everyone for the public part. We're going to go into